So what you see here is a list of all the formulas that you'll be given for your simple and compound interest exam, or it's part of the exam. And so it includes all of the formulas that you would need for simple interest. So those are in this area. So here's simple interest. So total interest is equal to principal times the rate times time, and usually we've done that in years. Finding simple interest final amount, the final amount here is equal to the principal that you started with plus the total amount of interest. That's what the I is. And then finding just the amount of interest that you earn, I is equal to A minus P, or the amount that you end up with the end minus your starting amount. Compound interest for future value is given to you here. So A represents the future value. And again, A is equal to 1 times bracket 1 plus I, all to the exponent n. And P for present value, that's our how much we need to invest right now. That's equal to, so present value is equal to future value times 1 plus I, all to the exponent negative n. Okay? I've tried to go over and give a sense of our what n and I are. People tend to have challenges with this particular one. N is always the total number of compounding periods. So for example, let's say that you had something that was compounded annually. Annually is compounded one time. Okay, and so if you went for 4 years, your N value would be 4. If, for example, you had a situation where something was compounded quarterly. Quarterly is 4 times per year. If it was invested for 4 years, then you'd have 16 compounding periods, and so forth. The I represents the rate of investment. Okay, so normally that's given to you as an annual percentage. So for example, at an annual rate of 4%, you have to always convert your R into a decimal. And then that would be divided by the number of compounding periods per year. So if something was compounded quarterly, that would be 0.01, because 4 divided by 0.04 divided by 4 is 0.01. So we'll go over that a number of times as we get through this particular section. Okay, so let's quickly start off by looking at simple interest. So let's say that someone named Jody invests $1,500 at 3.5% simple interest for 3 years. The key here is the term simple interest. When you see simple interest, you should be thinking of your simple interest formula. Okay, so simple interest formula, we know we've got I, P, R, and T. Okay, I represents the amount of interest that we're going to earn at the end. So in this case, how much interest will she earn? Well, that's our question mark, so we don't know. P is our principal amount, or our present amount, what we started with. Okay, so in this case, our present amount is $1,500. That's how much she invests today, and we want to figure out how much she's going to have a little bit later on. Our R value, we know that the rate of investment is 3.5%. And so we need to always convert the percentage into a decimal. So the R value is actually 0.035. So to get that, I did 3.5 divided by 100, and that gives me the percentage as a decimal. And then T represents time in years, and in this case, the question says that she invested for 3 years. So I'm going to fill in 3 there. So to set this up, because I'm trying to figure out how much interest she's earned, I'm going to use my simple interest formula. So I is equal to P times R times T. So that means that I is going to be equal to the things I substitute in here. So I'm going to substitute in $1,500 times 0.035 times the 3 years. Okay, and so when I multiply those 3 numbers together, let's quickly do that here. 1,500 times 0.035 times 3, that's going to give me 157.5. Okay, so her interest earned is $157.50. The next thing we want to figure out is how much is she going to have in total at the end of the investment. Okay, so the total amount, okay, is equal to the principal plus the interest earned. So we don't know the A value. Let's try that again. We don't know the A value. That's what we're trying to figure out. That's the total amount. We know that the principal, she started off with $1,500. And we calculated that the I value, she made $157.50 in interest. So if I substitute in my P and I value into this, I get A is equal to 1,500 plus 157.50. So my A value in total is going to end up being $1,657.50. Okay, so her total value at the end of the investment is $1,600 or $1,657.50. How would our solution change if we said that she invested it for only 3 months instead of 3 years? Okay, so we're trying to figure out what the interest earned over 3 months is going to be as opposed to 3 years. So in this situation, we are still looking for our interest value. We don't know what that is. We know what our principal is. Our principal is still $1,500. That's what she started off with. Our R value continues to be 0.035. Okay. What changes here is our time value. Okay. And so time is always a measurement in years, so we need to figure out what that's going to be in years. So 3 months is, as a fraction of 1 year, represents 3/12. Okay, there are 12 months in an entire year, so as a fraction, that would be 3/12. And we can actually convert that into lowest terms. So that's 1/4. And to make it simple to calculate, we can turn that into a decimal of 0.25. Okay, so in this instance, we're still going to use our I is equal to P R T. And we're just going to substitute in our P value of $1,500, our R value of 0.035, and now our T value, 3 months represents 1/4 or 0.25 of 1 year. That's our total amount of time. So in this case, we've got 1,500 times 0.035. Oh dear. Let's try that again. 1,500 times 0.035 times 0.25. That's our total amount of time. Okay, so if I plug all that into the calculator, $1,500 times 0.035 times 0.25, that means that in 3 months she earned $13 and approximately 13 cents in interest. Okay. How would it change? Well, her interest earned would be $13.13. If I wanted to figure out the total amount of money that she had, that would be my original $1,500 plus the 13 that she earned in interest during those first 3 months. So her total value at the end of 3 months would be 15, 13, 13.